Hello students, in today's video lecture we are going to discuss the types of salts in salt hydrolysis. Right, what are the various types of salts in salt hydrolysis? So first type is salt of strong acid and strong base. Right, for example NaCl. This is salt of strong acid and strong base. Strong acid here is HCl and strong base is sodium hydroxide. From these two components this salt is prepared. Next is salt of weak acid and strong base. For example sodium acetate. Acetic acid is the weak acid and sodium hydroxide is the strong base here. Right. Third category is salt of strong acid and weak base. For example ammonium chloride. Right, weak base is ammonium hydroxide and strong acid is HCl. Right, from these two components this salt is prepared. Right, now fourth category is salt of weak acid and weak base. For example sodium acetate. Right, we will write here not sodium acetate, we will write ammonium acetate. Right, CH3COO NH4 positive. Right, NH4 positive. Acetic acid is the weak acid here and ammonium hydroxide is the weak base here. From this component this salt is prepared. Now let us go into the detail of these salts. First is salt of strong acid and strong base. Strong acid for example HCl, strong base for example NaOH sodium hydroxide. From these components the salt sodium chloride can be prepared, and when the hydrolysis of this salt takes place, right, we will get sodium positive ion in aqueous and chloride ion in aqueous state. Right, now here neither cation nor anion will hydrolyze, that is solution is neutral in nature and pH will be 7 at 25 degrees Celsius. Now what are the various steps, right, for finding the degree of hydrolysis? First of all find which ion is hydrolyzed, right, and the nature of the solution we have to find this. Right, first step. Second step is write KH, that is the degree of hydrolysis. Right, and KH here is hydrolysis constant for ion hydrolysis. Right, third is write relation between degree of hydrolysis H and KH, that is hydrolysis constant. Right, this is degree of hydrolysis, we have to write the relation between them. Okay, after that H is degree of hydrolysis, we have to write degree constant hydrolysis, right, upon ionic product of water multiplied by Ka, that is dissolution constant of acid, or we can write Kh by Kw into Kb. This value it will be equivalent to 1. Right, and we can write the Ka and Kb formulas for the reactions. So this KH is hydrolysis constant for ion hydrolysis. Right, now fifth step is if solution is acidic, then we have to find the concentration of H plus. When we find the concentration H plus, then pH will be given by minus logarithm of concentration H positive. Right, and if solution is basic, we will find concentration of OH negative ion and then POH value, and we know POH is given by minus logarithm of concentration OH negative ion. Right, now we will take salt of strong acid, that is HCl, and weak base, that is ammonium hydroxide, right? And salt will be ammonium chloride here. Cation will hydrolyze, right? This is cation, ammonium ion. When it hydrolyze, it will form ammonium hydroxide and H plus. This is cationic hydrolysis. pH is less than 7 at 25 degrees Celsius, right? Now salt is acidic in nature, right? This is ammonium ion. When hydrolyzed, it will get base plus H plus. When time is 0, concentration C, it is 0 and 0. If time equivalent to T, then concentration it decreases C minus CH, it will form CH and it will form CH, right? H is the degree of hydrolysis. Now KH we will write here as ammonium hydroxide, that is NH4OH concentration, H plus divided by ammonium hydroxide, right? We have to write here it as we have to write here NH4 plus, right? Now its concentration is C alpha, its concentration is CH, right, and CH, and its concentration is C minus CH, right? KH will be given as C square H square by C into 1 minus H by taking C common here, and KH is given by CH square upon 1 minus H. If H is very less than 1, then we will write 1 minus H is approximately equivalent to 1. Now KH is equivalent to CH square, right? We can write CH square. From here H square can be written as KH by C, and H is written as simply under root KH by C, right? This is the formula for degree of hydrolysis. This is important formula, right? Now Kb for ammonium hydroxide, when it hydrolyzes, we will get ammonium ion plus OH negative ion. Kb we will write it as NH4 positive concentration OH negative upon ammonium hydroxide, right? Now we will write KH by Kw into Kb equivalent to 1, right, for this ammonium hydroxide. Now on cross multiplying KH into Kb, we will get Kw, and Kw is written as KH upon Kb, right? Here is H, right? If you want to write Kb here, right, we will write Kb here, and Kb it will be written as Kw by Kh, right, if you want to write Kb value. Okay, now this Kh by Kw into Kb, it is equivalent to 1. How? We will write this formula, right, and this is formula from the above equations, and these will get cancelled to each other and we will get 1, right? We will write it as this is Kb value, and this is Kb value, and here we have written Kb value, right, and in the similar way we have written this Ka value, right? Kb value, and above we have written the Ka value. Writing these values here, right? At one place we have written Kh by Kw, right? Kh upon Kw value, and at other place we have written Kb value. On cancelling we will get 1, right? Now concentration of H positive, it is equivalent to Ch, right? And H is given as under root Kh by C, and you can write it as Kh upon C into C square, right? It will become under root KHC. Now pH is given as minus logarithm concentration H plus, and pH minus logarithm H plus concentration is under root KHC. It will become power 1 by 2, right? Now it will become KH is KW by KB, right? And C is C. On solving we will get this pattern, right? And log m by n we will use here, plus log m into n, it will become log C. Okay, now on applying these formulas, right, and when we put this minus the into with these terms, right, and the negative will become positive and positive term will become negative, right? And we know pKw for the water at 25 degrees Celsius, it is 14, right? And when we solve this, it will become 7, and minus 1 by 2 will come here, and it will become this, right? So this is the formula for pH calculation, right? So in short, we can learn it as salt of strong acid weak base, it is cationic hydrolysis, pH less than 725 degrees Celsius, solution is acidic, KH is given by CH square formula, H is given by under root KH by C, right? Now KH by KW into KB, it is equivalent to 1. We will put the value of KH by KW into KB value, we will get 1, right? Now concentration H positive, we will get CH, and pH is 7, and this is pH is given by this formula, right? C is the concentration, right? And pKb is minus log Kb, right? Next case, if we take the salt of weak acid and strong base, then it will be anionic hydrolysis, pH greater than 7 at 25 degrees Celsius, right? Solution will be basic, and KH will be the formula, KH will be given by the formula CH square, and H is under root Kc by C. Okay, and KH by KW into Ka, it will become 1, right? And constitution negative, it will be CH, and pH is given by this formula KW upon 2 minus pKa plus log C, and pH is given by 14 minus POH, right? After overall calculation, we will get pH equivalent to minus 7 plus 1 by 2 pKa plus log C, pKa plus log C, right? And pK is minus log Ka, C is concentration of salt, right? Now if we take the salt of weak acid and weak base, right, this is weak base and this is weak acid. For example, this salt, right, sodium acetate, both cationic and anionic hydrolysis will occur. Okay, H is given by this formula, and KH is given by this formula KW upon Ka Kb, right? Now pH will be given by this formula if K is greater than Kb, which implies pK is less than pKb, and pH is less than 7 at 25 degrees Celsius. If Ka is less than, this is greater, right? If K is less than Kb, pKa is greater than Kb, which means pH is less than pH is greater than 7 at 25 degree Celsius. So next it will the solution will be basic. Okay, now if K is equivalent to Kb, then pKa value will be equal to pKb value. pH equal to 725 degrees Celsius. pH of salt of weak acid and weak base does not depend upon concentration, right? Concentration of the solution, it doesn't depend. Now I have written question here. The pH of 0.02 molar ammonium chloride salt solution is Kb for ammonium hydroxide is 10 raised to minus 5 and log 2 value is 0.3. Now how to calculate the value, the answer for this solution, right? So pH formula is given by this equation, 7 minus 1 by 2 pKb plus log C, right? We will write, when we will put this value 10 raised to minus 5 here, it will become 5, and concentration is given to us 0.02 molar. We can write 2 into 10 raised to power minus 2. When we put this value here, it will become 2 log 2, right? And on solving this problem, right, on putting log 2 value, we will get 7 minus 1.65, 5.35 is the required answer here, right? Okay, thank you.